In Unit 2, we've been talking about negative numbers on the number line, and that also includes absolute value. And if you notice, we have an example conclusion map that the 6th grade math teachers developed to kind of help explain a really challenging word problem that you're going to encounter during this unit, where we have to apply absolute value. And again, just a quick reminder, absolute value is really talking about a distance from zero, or in this case, maybe from sea level. So if we take a look, they give us an example here, and I'll try to zoom us in here a little bit so that we can see just the word problem for a minute. It says, how far is Hero Hawk from the lake? Well, if we take a look at Hero Hawk, and we kind of drew a dotted line across here, you'd be able to see that Hero Hawk shows a location of 50 feet. We want to talk about its absolute value, meaning how far away or a distance is he from the lake. The lake here is located at 0. It's kind of the same idea as sea level, and we're going to run into that more so in our unit than just talking about a lake. They'll talk about sea level. So I'm trying to figure out how far away that is. Well, if I were on an actual number line that I could visibly see, if I took one jump away from 0, heading upwards, I'd be at +1. If I took a second jump, I'd be at +2, a third jump at +3, a fourth jump at +4. So really I'm counting how many intervals it would take me to get up to this 50 feet. That's where this +50 or a distance of 50 jumps or intervals comes from. Hero Hawk is 50 feet from sea level. Let's look at another example. Example number 2. How far is the bird from his dinner? Bird from his dinner. Let me think about that a minute. Well, I see a bird. It is flying. It's above Hero Hawk, actually. What on earth would he eat for dinner? Hope he's not after Hero Hawk, but I think he could probably eat a fish. So it says, how far away is this? The distance. I really want to go from 65 feet to a -20 feet. I want to go from above sea level to below sea level. What did they do here in their example? Well, they talked about the distance of 65 feet being 65 units away from 0, and the distance to -20 on a number line would be 20 intervals, or a distance of 20 feet in this situation. So next it looks like they took the distance to Hawk and the distance to the fish. Oops, it's not Hawk at all, is it? We're talking about the bird now. The distance from the bird to the distance below sea level to the fish gets them a total distance of 85 feet. The bird is 65 feet above sea level, and the fish is 20 feet below sea level. So the bird is 85 feet from the fish. Oh, they added them together to find the total distance. One started out on the positive side of the number line, the other one started out on the negative side of the number line. Let's look at another example and see if we can interpret what's happening here. So example 3, how far is Hero Hawk from the bird? Oh, Hero Hawk, I saw him a minute ago. Remember, we drew this dotted line just to kind of show he's at about 50 feet above sea level, and now it compares him to the bird. How far away is he from the bird? Well, the bird is even above him, isn't it? Well, what do I want to do with these two distances? They're pretty close to each other. If I add them together, I'm not sure that would show me the difference. So what did they do down here? Let's take a look in their example. Well, the 65 really represents the bird, doesn't it? The bird was 65 feet above sea level, and that distance would mean 65 is its absolute value. Well, here 50 represents where Hawk was, right? This is Hero Hawk, so I'll just write Hawk here, and that actually put him 50 feet away from 0. Well, we know that they aren't a combined or combination of those two amounts. I don't want to add like I did on the last one. It looks like they decide to subtract. That's kind of like, I know I'm really old, and I know that you're younger than me. So if we did a subtraction, we could figure out the difference in our ages. We could figure out how close we are to each other in ages. Well, that's kind of what we're doing here. We take the farthest distance, the bird, and we take away the smaller distance, the hawk, and see what we get. Looks like they got 15. Hero Hawk is 15 feet away from the bird. All right, what do they do for example 4? How far from sea level is the fish? How far from sea level is the fish? Well, we talked about the fish a minute ago, but now they're saying how far away from sea level is he? How far to the very beginning of the lake here, or this 0, which we marked sea level? Well, that again is talking about a distance. Anytime they say how far, how far, how far, how far, we're talking about absolute values. We're talking about a distance away from things. And then my classroom lights went out because I sat too still. So let's try that again. Notice they put in absolute value bars this -20 because that's the location of the fish right now. Well, the absolute value of -20 means it's really 20 jumps away from 0. So the fish is 20 feet from sea level. No addition or subtraction on that one. We want to come up with a conclusion, easy for me to say. And I have to tell you that these example conclusion maps are very much geared towards looking at examples and trying to learn from what you're seeing. So it's not necessarily practicing a bunch of problems along this line. It's kind of looking for similarities and maybe differences that can give us a rule. Well, I noticed something. I noticed that when it said how far every single time, what did we have to find? Oh, that's right. We found the distance or the absolute value. So to find how far something is, I use absolute value. And this was really true for 2 of these examples if you look. Which 2 were just straightforward absolute value or distance? No other things needed, no operations. Example 1, just an absolute value and then a result. And example 4 over here, just an absolute value and a result. So this rule goes well with, oops, I was going to write it in parentheses for you, examples 1 and 4. That probably means that there could be some more conclusions here. Can we look at example 2 and see if we can write a conclusion? Notice when one number starts positive on the positive side of my number line and the other number starts negative on the negative side of my number line, and I'm looking for a total distance, they told me to find the absolute value and then add. I think that's another rule. So I'm going to come up here and I'm going to write another conclusion. So to find the distance between 2 objects or numbers, and they're on different sides of 0, right? On different or opposite sides of 0. I do what? What did we have to do again? When one was on the positive side and the other one was on the negative side and I was looking for total distance, I really had to add. There's this addition happening here. Excuse me. So I add the absolute values. Well, hang on, there was another example, and we haven't talked about it yet. So this really came from example number 2, where it talked about the bird getting his dinner. That means that example 3 we haven't mentioned. There might be a third conclusion. I know that when we revise our maps, we have to include a third conclusion. Well, to do what? So what's the third thing that we looked at? It wasn't just a straightforward absolute value to find how far something was away. It wasn't when 2 numbers were on opposite sides of 0. Look, these 2 numbers were on the same side of 0. They're both positives this time. Or this would probably be true if both the numbers were negative next time. So to find absolute value, nope, sorry, we're looking for the distance. To find the distance between 2 numbers or objects that are on the same side of the number line, meaning both positives in this case, or maybe both negatives next time. What did I do? I didn't add this time. I had to find their difference. The difference between them. This is kind of a key word that kind of reminds me of what we did here. So difference goes with subtraction. I subtract their absolute values. I really think this skill is kind of important when we talk about reading a math textbook, and if you go online and ever look at Math in Focus in particular, they're going to give you a bunch of different examples, and they might not come right out and tell you a rule. They kind of develop the examples and then leave it to you to develop your thinking around it. So this is very much a procedure that I think is going to be helpful as you move ahead in any math class, is really how to interpret examples and how to learn from them. So I hope that this example conclusion map involving absolute value might help you as you move ahead into lesson 2.2 and those challenging word problems. And remember, we kind of summarized here, these are the important pieces. Different sides, we had to add. Same side, we had to subtract. Those are the two things that we're really going to try to use as our takeaways from this lesson.